All right, number 14. So we're finding the power for each one of these resistors. So we're going to have to use the power equations from last chapter. P equals I delta V, P equals I squared R, P equals voltage squared over R. So these are the three power equations. My favorite one is this second one because we already have the resistances. We already have the resistances of each resistor. So if you can find the current going through each one, then all you got to then take current squared multiplied by the resistance. Okay, but you know what? I'm gonna solve for the power of this guy and this guy using that equation, and then for these two guys, just to show you how it works, I'm going to use this other equation, number 3, right? Just so you can see how to do it. All right, so if you don't have the power equations copied, copy those down. Now, let's label our currents. So we have 3 different currents in this circuit, and when you're labeling currents, you want to start at the battery. Current comes out of the battery. It's positive charge motion. So let's call this current I. And then right here, it splits into I1. We'll call this current I1. And then this current here is I2, just like a fork in the road, right? Some of the charges go one path, some of the charges go the other. So that'd be I2 right there. And then what happens at this point right there? I1 and I2 come back together again, and we have I. So we got 3 currents, I1, and I2. Okay, now the key to circuit problems is to simplify. So the first thing that we want to simplify here are these 2 resistors that are in parallel, right? Because didn't the circuit split right there? It branches. So that means the 3 and the 1 are in parallel with each other. So the way you simplify resistors in parallel, you use the 1 over equation, and then these guys are going to simplify to 0.75. You go like this. 1 over the equivalent is 1 over 3 plus 1 over 1. That simplifies to 3, no, not 3 over 4, 4 over 3. So you flip that and you get 3/4. Okay, so redraw it. Don't be lazy. Hey, man, don't be lazy. You got to redraw the whole picture, just simplified. Like this. Shh. Dude, chill. I do have peripheral vision. Mellow. Physics time. Okay, so there's the 2. There's the 4. This guy right here is the 0.75. Like that. Okay, what current is flowing around this circuit? I. Right? It's the current out of the battery. And one thing we've talked about is that when you have resistors in series, the current's the same. So all 3 of these resistors have the same current, right? Now, one more picture. We're going to simplify again. So the way that you simplify resistors in series is you add them up, right? So we go 2 plus 0.75 plus 4. That adds up to 6.75. And then that's 18 volts. The current flowing around this circuit here is I. So look. We can, now what you do, and this is not just for this problem, but for problems in general for circuitry, you start with the most simplified picture and you start to work your way back. Now look, this is the nicest of all situations. 1 battery, 1 resistor is nice because the voltage of the battery must be the voltage of the resistor. And here's why. If that's an 18-volt battery, what are we saying? Positive plate is 18, negative plate is 0. So how many volts are over here? 0. How many volts are up there? 18. So how many volts are across that resistor? 18. That's the easy, and that's the only time it's true. If the voltage of the battery equals the voltage of the resistor when you have 1 battery and 1 resistor. So now to find I, you go delta V equals IR. That's Ohm's law. So that's delta V over R. We have 18 volts across that resistor. And then the resistance is 6.75. So this gives us a current of 2.6 repeating. So I, the current here in this diagram is 2.6 amps repeating, which means up here it's 2.6 amps repeating, 2.6 amps repeating, 2.6 amps repeating. Okay? So we're figuring stuff out. Check it out right here. What's this current? 2.6 amps repeating. What's this current right here? 2.6 amps, right? We figured out what I is, the current out of the battery. So now, let's go ahead and find the power of this guy and that guy, right? So how do we find the power of that guy? You go P equals I squared R. So P is going to be 2.6 repeating. That's important, because it's especially important because it's squared. And then the resistance is 4. So this gives a power of 28.4 watts. That's the power of the 4 ohm. Okay, then go to this guy. P equals I squared R. So the current is 2.6 repeating squared, and then the resistance is 2. So that gives a power for the 2 ohm of 14.2, which makes sense. It's half of the other guy, half the resistance. Okay, power is in watts. All right, now, how do we find the power of the other 2 guys? How do we get the power of these guys? Well, my screen has gotten quite messy, so I'm going to have to revert this back. But so make note of everything we have here. Make note. So here's what we're going to do. All right, so we know that the current here was 2.6 amps. The current there is 2.6 amps. So what I'm going to do for these 2 resistors here, I'm going to use P equals delta V squared over R. I'm going to use that power equation. Now, so what do we got to figure out for these resistors? The delta V. Hey man, what's the #1 way kids tell the grader that they have no idea what's going on? They see V right here, they go, ooh, there's a V, plug it in. Is the voltage across these guys, is the voltage across the 3 and the 1 18? No, that's the voltage of the whole circuit. Okay? So, how do we get the voltage across these resistors? Well, here's how I like to do it. This is the Spaldo way. It's the best way. So battery is 18, right? That's 18 and 0, right? That's what we mean. It's a delta V. So how many volts do we have at this point? 18. Now, what happens when we cross this resistor right here? This first resistor. The voltage goes down. By how much? Can we figure out how much? Yeah, because we have I and R, right? Delta V equals IR. It turns out that the voltage drop across this guy, when you do Ohm's law, the voltage drop across this guy is, did I write it down here? I did not write it down. So what is that going to be? 2 times, so 2.666 times 2. It's 5.33. The voltage across this guy is 5.33 volts. So how many volts are we going to have here? Well, you go 18 minus the 5.33 leaves us with 12.6 repeating for that point right there. Same thing with right here. This point right here would be 12.6 repeating. Now, down here, this is a little trickier. You got to think backwards. So look, right here is 0 volts. So over here is going to be higher volts, right? Because when you cross this guy, you're going to lose volts. So how many volts do we lose across this guy? Well, just do Ohm's law. Delta V equals IR. So that's going to be 2.66 times 4. This is 10.66. The voltage across this guy is 10.66 volts. So this point right here, if over here is 0, what must this point be? 10.6 repeating. So now, we got it made, dude. We got it made. How many volts are across this? Well, look, 12.6 and 10.6. What's the delta V across this guy? 2. What's the delta V across this guy? 2, right? And the thing that we said, voltage across resistors in parallel is always the same. When you cross resistors in parallel, the voltage will be the same across those resistors. So now let's do the 3 ohm. So for the 3 ohm, the voltage across him is 2. The resistance is 3 ohm. So this gives a power of 4 over 3. So what's that? 1.3 repeating. And then go to the 1 ohm. P equals delta V squared over R. So that's going to be 2 volts squared over 1. So that gives 4 watts. It's like a puzzle. Hey, now look. I want to just say one other thing before the period's over. One other thing. Hey, figuring out the voltage here, was that the way I did it, was that the only way you could have done it? Hey, go look at your medium simplified diagram. The one that I erased that looks like this. Just check it out. Hey, just check it out. Look at this one right here. So this is 2 ohm. This was 0.75 ohm. And then this is 4 ohm. Look at, who is this 0.75? Who is that guy? It's these guys, right? If you can find the voltage across that guy, you found the voltage across those guys. And just check out what it would be. What's the current flowing through that circuit right there? That current was what? 2.6. Look at, what's 2.6 times 0.75? 2. It's the 2 volts. It's easier. But, yo.
How would you find I if there are 2 batteries? So like more.
If there's multiple batteries? Well, that depends. Are they in the same branch of the circuit or different? If they're in the same part of the circuit, if the batteries are in series, you can just add them together. If they're not in the same branch, then you have to use something called Kirchhoff's rules, which is like voltage gain equals voltage loss. We're going to look at a lot of different problems. Did you come across one like that? Did you come across a problem like that already?
No, it's just out of curiosity.
Oh, we'll look at some like that.